Now let's just recall some of the basic terms and their definitions which would be related with this chapter. So let's just start with the very first term, which is nothing but called as a line segment. So what is a line segment? A part or a portion of a line with the two end points is called as a line segment. So this is nothing but called as a line segment, which is nothing but a portion of a particular line having the two end points, specific two end points. This is nothing but called as a line segment. And further, let's just see the second definition, which is a ray. So a ray is a part of a line with one end point is called as a line ray. So this is nothing but called as a ray in which it has one end point, only one end point, and the line is moving on further from the other end, which is nothing but called as a ray. Now further, there are some of the notes that are related with the line segment and the ray. So a line segment AB is always denoted by AB line segment and its length is denoted by AB. And if we are talking about a ray, so a ray is denoted by AB with a symbol of ray on the top of it, and its length is denoted by AB in such a manner. Moreover, there is another special note which is related with it, that a particular line is represented by LMN. So the small letters LMN will also be used to denote the lines. So this is nothing but all about the definition of the line segment and the ray and some of the notes that are related with it. Now let's just move on further and talk about the collinear points. What are collinear points? So if three or more points are lying on the same straight line or lying on the same straight line, they are called as nothing but the collinear. Otherwise, they are called as the non-collinear points. So let's just see an example of collinear. So first of all, if I'm just talking about these 3 points, you can see these 3 points are lying on the same straight line. That's why they are called as the collinear points. And let us suppose if I'm just taking an example of these 3 points, can you see these 3 points? These 3 points are not lying on the same straight line. That's why they are called as the non-collinear points. So always remember that collinear points are nothing but the points if they are lying on the same straight lines. Means if 3 or more points lie on the same line, then they are called as the collinear. Otherwise, they are called as the non-collinear point. Now let's just move on further and talk about the angle. What is an angle? An angle is formed when two rays originated from the same end. So let us suppose if I'm just talking about this particular end. So from this end, these two rays are originated. These two rays are originated from this particular end, and hence this end is nothing but called as a vertex. This end is called as a vertex. And as you can see over here, that the angle is actually formed. This is nothing but the angle, and this is originated when the two rays are coming from the same end. Now these two rays do have a specific name. These two rays are actually called as nothing but the arms of the angle. So the rays, these rays that are making an angle in between, they are called as the arms of the angle. So hence this is all about the angle. That angle is formed when two rays originated from the same end, and that end is nothing but called as the vertex, and the two rays are specifically called as the arms of the angle. Now let's just move on further and talk about some of the angles. So first of all, we know that what is an acute angle. An acute angle is the one which is lying in between 0 degree and 90 degree. This is nothing but called as an acute angle. Now what is a right angle? Right angle is nothing but specifically an angle which is nothing but is equal to 90 degree. So as you can see over here, this y is equal to 90 degree. So this is nothing but called as a right angle. And what is an obtuse angle? So as you can see, this z angle is actually nothing but called as an obtuse angle, and the obtuse angle measure is always lying in between 90 and 180. So it is lying in between 90 and 180. Now let's just talk about the other type of angle which is called as the straight angle. So what is a straight angle? In this straight line, this particular angle S is nothing but called as a straight angle, whose measure is nothing but is equal to 180 degree. Now further, you can see such kind of an angle which is nothing but of the form angle T, and this angle is called as the reflex angle, such that its measure is lying in between 180 and 360. So you can see over here, this is a reflex angle whose measure is actually lying in between 180 and 360. So these are the different kind of angles we have already dealt with. So acute angle, always remember we have acute angle, right angle, obtuse angle, straight angle, and reflex angle. These are the different types of angles we already know. Now let's just further talk about the complementary angles. So what are the complementary angles? So two angles whose sum is 90 degree, they are called as complementary angles. They are called as complementary angles. So always remember, whenever the sum of the two angles is 90 degree, they are called as complementary angles. Now in the same way, we are talking about supplementary angles. What are supplementary angles? Two angles whose sum is 180 degree, they are called as supplementary angles. So complementary angles, supplementary angles. Now let's just move on towards the specific type or the special type of the angles that are called as adjacent angles. What are adjacent angles? Two angles are adjacent if they have a common vertex, a common arm, and their non-common arm are on the different sides of the common arm. What does it mean? Let us suppose if I am talking about the two angles over here, you can see the two angles. This is the angle ABD, and the other angle is CBD. So they are two angles, ABD, and this is CBD. Now first of all, you can see over here that they have the common vertex. They have the common vertex. They have the common arm. The common arm is nothing but BD. Their common arm is BD, and their non-common arms, they are on the different sides of the common arm. You can see all by yourself that BD is actually their common arm, and BA and BC are the non-common arms that are on the different sides of the common arm. So that's why these angles are called as the adjacent angles. So always remember, two angles are adjacent angles if they have a common vertex, if they have a common arm, and their non-common arms are on the different sides of the common arm. So hence here ABD and CBD are actually nothing but called as the adjacent angles. So there are some of the other things that are also related with the adjacent angles. So let's just see what are those. So first of all, if I'm just taking the same adjacent angles, so the very special note that is related with the adjacent angle is when two angles are adjacent, then their sum is always equal to the angle which is formed by the two non-common arms. So this is quite an obvious thing. You can see all by yourself that if I'm just talking about this angle, if I'm just talking about this angle, so these two angles are adjacent, and if I'll take the sum of these two angles, this would be the total whole angle, which is nothing but ABC. So this is a special note which is related with the adjacent angle. You can see angle ABC is nothing but is equal to the angle ABD plus the angle DBC. So the angle ABD plus DBC is nothing but equal to the whole angle, which is nothing but ABC. So always remember, whenever we are just talking about the two adjacent angle, so the sum of the two adjacent angle is nothing but is equal to the whole angle, that is nothing but formed by their two non-common arms. So their two non-common arms are nothing but BA and BC. So this is nothing but a concept which is related with the adjacent angles. Now let's just talk about a particular question. So let us suppose if a question arises regarding this particular figure, there is a question that arises in my mind, and what is that? Angle ABC and angle ABD. So let's just see. ABC, I'm talking about ABC, means I'm talking about this whole particular angle, and the other angle is ABD. So this is angle ABD. So I'm talking about this whole angle, and I'm talking about this angle, that is ABD. So the question arises over here is, ABC and ABD are not adjacent. They are not adjacent. Why they are not adjacent? So you can see over here that for ABD and ABC, AB is actually existing as a common arm. This is existing as a common arm. A, B, D, and for A, B, D, and for A, B, C. AB is nothing but a common arm. this is nothing but a common arm. And you can see by the definition of the adjacent angle, the adjacent angles are made in between or with the same vertex. They do have a same vertex, they do have a common arm, but their non-common arms should be on the different side of their common arms. So they are actually on the same side, of the common arm. You can see over here that BD and BC, their non-common sides are actually lying on the same side of the common arm. So it means that they are not adjacent. So the reason over here which is related with this question is that they are not adjacent because of the reason that their non-common arms are not on the different side of the common arms. That's why they are nothing but they are not called as the adjacent angles at all, because by the definition the adjacent angles are formed in between the same vertex. They do have a common arm, they do have the two non-common arms that are lying on the different side of the common arm. So they are not on the different side of the common arm, and that's why they are nothing but they are not called as the adjacent angles at all. So this is the reason related with this particular question. Now let's just talk about another kind of angles which are called as the linear pair of angles. So what are linear pair of angles? Let us suppose if I'm just again talking about the adjacent angles, but here the non-common arms of the adjacent angles, they are actually forming a line. You can see all by yourself that this ABD and DBC, they are the two adjacent angles, but their opposite arms are actually, or their non-common arms are actually forming a line in such a way. So they are forming a straight line over here in such a way. So such a type of angles, now they are called as nothing but forming a linear pair of angles. So here we can say that the angle ABD and the angle DBC are the linear pair of angles because they are forming a straight line over here. Their non-common arms, they are forming a straight line over here. So that's why they are nothing but called as the linear pair of angles. So hence this is nothing but all about the linear pair of angles. Now let's just further talk about the special type of angles that are called as vertically opposite angles. What are vertically opposite angles? When two lines intersect each other at a particular point, they form two pairs of vertically opposite angles. So let us suppose if I'm just taking the two lines and their point of intersection as 0. So here you can see we have the two vertically opposite angles, and what are those? So the very first is nothing but this one, and the second is nothing but this one. So let us suppose if I'm just talking about the angle DOA and the angle DOA and the angle COB. This is the very first pair, and the second pair is nothing but the angle AOC and the angle BOD. These two pairs are nothing but called as the vertically opposite angles. These are called as the vertically opposite angles. So hence these are called as the vertically opposite angles. So these are the vertically opposite angles, and this is nothing but a second pair of vertically opposite angles. So always remember, when two lines intersect each other at a point, they form two pairs of vertically opposite angles, and they are nothing but called as the pair of vertically opposite angles.